Okay, so this is going to be a quick recap of section 3.5, which is rational functions. We were working on this before we left for the break. So this we had kind of covered these topics. We're going to just kind of do a quick recap on this. It's been a while since we've looked at the math stuff. So what we're going to do is we're going to kind of look at vertical asymptotes. We're going to look at horizontal asymptotes and oblique asymptotes. How do we find each of those cases? And then we're going to go through and look and see how do we graph functions in each of those cases. So to get started here, let's say vertical asymptotes. Basically, to figure out a vertical asymptote, this is x's that make the denominator equal to 0. So for a quick example, suppose we had y equals x minus 1 over x squared minus 2x minus 3. And we wanted to figure out where is the vertical asymptote. I'm going to use VA in this section for vertical asymptote. So we want to say, okay, where's the vertical asymptote? So basically what we do is we say, okay, let's look at the denominator. Let's look at the bottom part here, which is x squared minus 2x minus 3. And we want to figure out where is the bottom part. Where is that equal to 0? So we can solve this by factoring. So we get x and x. We get a minus 3 and a plus 1. And then we can set the x minus 3 equal to 0 and get x equals 3. And we can set the x plus 1 equal to 0 and get x equals negative 1. So these are the x values where the vertical asymptotes occur. So vertical asymptote's pretty easy. Just look and see who's in the bottom of the fraction. These fraction types. These are rational functions, so they're basically a polynomial in the top and a polynomial in the bottom. So you look in the bottom here and say, okay, what's the bottom polynomial? Set it equal to 0, solve it for x, and that's basically it. Okay, so the next three things we're going to kind of write down are the three different cases for the other types of asymptotes. So this is going to be for horizontal asymptotes and oblique asymptotes. So we're going to kind of write down the three cases, and then we'll go through and look at some examples of how does each case work, and then we'll talk through graphing some of these, and then that's pretty much the section. So we're going to go and say, all right, first of all, we could say what about the degree of the top is less than the degree of the bottom. So this is the first case. This will create a horizontal asymptote. So I'm going to use HA for horizontal asymptote. This will be a horizontal asymptote at y equals 0. So basically, if the top is smaller degree than the bottom, again, degree, if we kind of scroll back up to this previous problem, this top part here is really x to the first power. So the degree is basically, if you multiply everything out, what's the highest power in x in the top, and what's the highest power of x in the bottom. So in this case here, x to the first power is in the top, you get an x squared in the bottom, so the top's degree 1, the bottom's degree 2. So this would be a case where the degree of the top is less than the degree of the bottom. So for this previous problem we did, it would have a horizontal asymptote at y equals 0 because of that. Second case, what about if the degree of the top is equal to the degree of the bottom? In this case, we get a horizontal asymptote at y equals the leading coefficient of the top over the leading coefficient of the bottom. And we'll talk through what does leading coefficient of top over leading coefficient of the bottom mean. We'll talk through that in an example here in just a second. Finally, what if the degree of the top is bigger than the degree of the bottom? No longer do you get a horizontal asymptote, you get an oblique asymptote, so we'll just call it oblique. Really it's oblique asymptote, but we'll say oblique. and this occurs at y equals the quotient of the division. So we're going to do kind of an example looking through how do we figure out the asymptotes of each of these three cases, and then we'll go through after that and we'll say how to solve graphing some of these things. So let's put a little line there, say okay, let's look at this example. Okay, so we want to find horizontal or oblique asymptotes. So we got case A. How about if y equals x plus 2 over x squared minus 4x plus 1? Case B. What if y equals 2x squared minus 4x plus 3? All that over 5x squared plus 2x plus 1. And case C, what if we had y equals x squared minus 2x plus 1, all that over x minus 3. So in the first case, the degree of the top's 1, so degree top is 1, the degree of the bottom equals 2. So the degree of the top is less than the degree of the bottom. So in this case, we have a horizontal asymptote at y equals 0. The top is smaller than the bottom, so this generates a horizontal asymptote instead of an oblique, because we're in the first case from what we just did, where the top was smaller, and it's at y equals 0. For the second case, the degree of the top, well, the top is an x squared, you can see right there, so it's degree 2. Degree of the bottom is also an x squared, so it's 2 as well. And so what we get is a horizontal asymptote at y equals the leading coefficient of the top. So y equals leading coefficient of the top is the 2 in front of the x squared term over the leading coefficient of the bottom, which the leading coefficient of the bottom is the 5 over the x squared term. So this right here tells me where my horizontal asymptote occurs at. And then over here for part C, the degree of the top's 2. And the degree of the bottom is 1. So the top is a bigger degree than the bottom. So what that says we have is a case where we get an oblique asymptote, and it's oblique asymptote at y equals the quotient of the division. So we have to say, okay, well, what division are we talking about? We're talking about the polynomial division that's listed in the rational function. Since the denominator here is of the form x plus k or x minus k, since it's x minus 3, we can do this division with synthetic division. So 1 is x squared's number, negative 2 is x's number, 1 is the constant term. We're trying to divide it by an x minus 3, so we put a positive 3 out to the side. We bring down 1. 3 times 1 is 3. Negative 2 plus 3 is 1. 3 times 1 is 3. 1 plus 3 is 4. This is the remainder. 4 is the remainder. This is no x's number. This is x to the first power's number. So we get y equals x plus 1. This is the quotient. So quotient is this. Remainder is that. And from what we said, the oblique asymptote occurs at the quotient. So y equals x plus 1 in this case would be where our oblique asymptote occurs. So we basically, at this point, we kind of covered how to find all the asymptotes. For the vertical asymptotes, you guys just set the denominator equal to 0, like we saw here. Look at the bottom, who's in the bottom, set it equal to 0 and solve. For the other cases, if you want to find horizontal asymptotes, or horizontal asymptotes or oblique asymptotes, that depends on how the degree of the top compares with the degree of the bottom. So we're going to put this all together and we're going to actually graph some of these rational functions. So there's kind of 4 different types I want to graph. We're going to go through and let's say graph y equals x plus 1 over x minus 2. This will be the first one we want to graph. And then we're going to graph 3 more types. So when you guys want to graph these, there's kind of 3 bits of information to need. You need to know where are my intercepts, my x and y intercepts, so I need intercepts. I need to know where are all my asymptotes, so this is vertical and horizontal or oblique, whatever types I got. And then I need to see, can we ever cross the horizontal or the oblique asymptote? So let's look at intercepts first. To get the x-intercept, you set the top equal to 0. So you think what x value would cause the top to be 0? The top's x plus 1. We say, okay, well, either I could set x plus 1 equal to 0 and solve it for x, which would give me x equals negative 1. Or I could think, what x value do I put in here for x to make the top 0? And I can get x equals negative 1 that way. So that's my x-intercept. For my y-intercept, I set x equal to 0 in the equation. So the top becomes 0 plus 1, the bottom becomes 0 minus 2. This gives me negative 1/2. So I just put zeros in where the x's are. Vertical asymptote, we saw this is where the bottom is equal to 0. So we say, okay, the bottom's x minus 2. What x would make the bottom 0? That'd be x equals positive 2. So vertical asymptote occurs at x equals positive 2. And then the other asymptote, we got to think about it. This is x is 1 over 1. So we're in the form where the degree of the top is equal to the degree of the bottom because they're both degree 1. So we say, okay, we're going to have a horizontal asymptote because this is that second case that we had up there. And it occurs at y equals the leading coefficient of the top, which is the 1 in front of the x here, over the leading coefficient of the bottom, which is the 1 in front of the x in the bottom. So this occurs at y equals 1. Then the final thing we see is, do we ever cross the horizontal asymptote or the oblique asymptote? In this case, it's a horizontal asymptote. So what you do to check that is you set the horizontal asymptote value equal to the original equation, and you solve it for x, and you see, does the solution you get back make sense, or do you get something weird like 5 equals 2? So I'm going to multiply the x minus 2 across. The x minus 2 multiplies up to 1. 1 times x minus 2 is x minus 2. So we say, okay, we got down to here. Let's subtract an x from both sides. That completely cancels, and we get negative 2 equals 1, which is not good. So no, in this case, there is no crossing the horizontal asymptote. So let's plot all our points on our graph. We say, okay, x equals negative 1 is an x-intercept. X equals negative 1/2 is my y-intercept. A vertical asymptote is going to occur out here at positive 2. And a horizontal asymptote's out here at 1. So what the possibilities of the lines when we go to connect through this, basically these functions come into the viewing window and leave the viewing window running alongside the asymptote. So we're going to basically got to decide, does our function do something like this or something like this? Is it a top curve or a bottom curve on this side, and then after the vertical asymptotes hit, do we come back down and run along the asymptote, or do we come up from the bottom and run along like that? So we got to decide which of these cases does our function look like. Well, to the left of the vertical asymptote, if you guys are going to clip these two intercepts, if your line is up here on the top side, you can't clip these two intercepts. So we have to, because of where the x and the y-intercept fall, our graph is going to have to kind of fall down here in the bottom side in this situation. And then we say, okay, well, how do we determine between a curve down here and a curve up here? Well, we found all the x-intercepts. There's only one x-intercept, and it's over here at x equals negative 1. So that means that there's no x-intercepts in this region right here. So since this little region I'm circling here, there's no x-intercepts. No x-intercepts there. So since there's no x-intercepts there, if I was to draw my line coming in from the bottom like that, that would clip the x-axis, which would create an x-intercept. And we can't have that. So that's going to force the rest of the graph to kind of be up here on the top side. And then just to kind of check our graph, again, these graphs aren't going to be like 100% accurate, but just to kind of check our graph versus our drawing, let's graph this really quick in Desmos and just take a look. So we said, okay, it was x plus 1 all that divided by x minus 2. And our graph looks like this. Desmos graph looks like that. So they're pretty similar. We can see that obviously Desmos does a better job of it, but it looks about the same. And we can see right here this line y equals 1. That's the line that both of these graphs approach without crossing. That's our horizontal asymptote, even though it's not drawn in. So this is something else I should say. When you graph these dotted lines, they're dotted because they're not actually part of the graph. Like you can see here that you don't have the dotted lines there, but we kind of use them to indicate, and kind of use them as to kind of indicate how the graph goes. So we do, if you do graph these, we actually I'll just leave that open in case you want to graph another one later. We do use the dotted lines in order to kind of use as guidance for where where the lines you're drawing go. Okay, so let's get our other couple examples out of here. So that's a case where the degree of the top is the same as the degree of the bottom. This is kind of the case 2 type. Let's look at a different one. So for this example here, let's say we want to graph y equals x minus 1, all that over, let's say, x squared minus 3x minus 10. So, okay, we need the x-intercept. This is where the top equals 0. If we look at the top, we could say the top's x minus 1. X minus 1 would be 0 if x is positive 1. So we get x equals positive 1 for our x-intercept. Our y-intercept is what happens when you set x equal to 0. So I get 0 minus 1 over 0 squared minus 3 times 0 minus 10, which is going to give me a negative 1 over a negative 10, which is 1/10. So I have a y-intercept at 1/10 in this case. Say, okay, vertical asymptote, where's the denominator? Where's the bottom equal to 0? So our bottom is x squared minus 3x minus 10. So I set that bottom equal to 0. And I say, okay, where is that going to occur? So we got to factor it. We say, all right, this will be x minus 5 times x plus 2 equals 0. So multiplies to negative 10, adds up to negative 3. So we say, all right, this is where x minus 5 is 0, or x plus 2 is 0. So x is 5 is one vertical asymptote. X is negative 2 is a second vertical asymptote. So this one it's going to have two of those dotted up and down vertical lines. So now we need to say, okay, where do we find our other asymptote? The top is degree 1, the bottom's degree 2. So we have a horizontal asymptote. Since the top degree is smaller, this is going to be a horizontal asymptote at y equals 0. So we got a horizontal asymptote at y equals 0. And now we say, do we cross that horizontal asymptote in this case? So I'm going to set 0 equal to the function. Set 0 equal to the whole equation, x squared minus 3x minus 10. And we solve it for x, and we see, do we get a point where we can cross the horizontal asymptote? So I'm going to multiply the bottom across. X squared minus 3x minus 10 gets multiplied by 0. When we multiply anything by 0, it becomes 0. The negative 1 I add across is positive 1, so I get 1 equals x. So I am able to cross the horizontal asymptote in this case, and it occurs at x equals 1. So now I'm going to just go through and try to graph all this stuff. Draw a better line here. good enough, I guess. Okay, so there's our graph. We got an x-intercept at x equals 1. We have a y-intercept at 1/10, so that's right here. We have a vertical asymptote at 5. A second vertical asymptote back here at -2. And our horizontal asymptote is at 0, which runs along the x-axis. So we're not going to draw it in, but we'll just keep in mind that it's running along the x-axis. Unfortunately for this type, like the other type, we could kind of see, use where the x-intercepts fell, and that told us which region to put in the graph. So like, for example, the two x-intercepts were down here below the horizontal asymptote. So that's how I knew that curve went on the bottom side. For this one, we're going to have to do something a little annoying, which is we're going to have to grab a particular x value, because there is no x-intercept out here to help us. So we're going to grab an easy to work with x value. So we'll say like -3. We're going to plug -3 in for the x's in our equation. And we're going to see what does the equation return. And depending if that's a positive number or a negative number, we're going to use where that dot's returned to figure out what side of the graph stuff should go on. So if I put -3 in for this, I'll just do the scratch work. I'm going to kind of create a little region here for scratch work. We'll have -3 minus 1 over -3 squared minus 3 times -3 minus 10. -3 minus 1 is -4 over, let's see here, that's 9 plus 9, which is 18. Take away 10, which is 8. -4 over -8 is -1/2. So at -3, we're over here at -1/2. Or let me get rid of that 3, because that's right in the way of where my dot's going to go. So we're at basically -1/2 at x equals -3. Put the number up there. So since that dot's on the lower side of the x-axis, that's going to force the first part of my graph to head downwards. Now we got to decide when we get to the x-intercept here, do we come down from this vertical asymptote and kind of get over there? So, or do we do a curve that's kind of like this? Or do we come up from the bottom and get there? Well, since our y-intercept is here at -1/10, if we come down from the top, we're not going to be able to get there, because the only place we cross the horizontal asymptote's at 1. We can't cross it over here. So that's going to force my graph to come back up from the bottom and hit my x-intercept like that. And then we say, okay, we've got that part there. Let's look at what about a number between x equals 1 and x equals 5. So we'll look at x equals 2. So if I take 2, I put 2 in here, I get 2 minus 1 over 2 squared minus 3 times 2 minus 10. 2 minus 1 is 1. 2 squared is 4. 4 minus 6. 4 minus 6 is -2. -2 minus 10 is -8. Let's see. 2 minus 1. Sorry, this is 4. 4 minus 6 is -2. -2 minus another 10 is -12. So that's going to be there at -1/12. So this comes back down kind of like that, I guess. And then out here beyond 5, we look at 6. And we'll say, okay, if I have 6, then 6 minus 1 over 6 squared, which 6 squared is 36, minus 3 times 6 minus 10. Let's see, 6 minus 1 is 5. 36 minus 18 minus 10. 36 minus 10 is 26. 26 minus 18 is 8. So we get a positive 5/8, and I think our graph looks like this. We're going to verify that with Desmos real quick and just see. if we've made a mistake somewhere, and then try to figure out what was the mistake if we made any. So we want to know what's x minus 1 divided by, so we got x minus 1 divided by x to the second power, minus 3x minus 10, and we're going to turn off the first graph. Okay, so this looks completely different than what I got there, so obviously I made a mistake somewhere. Okay, here's where the mistake was made. My y-intercept was here at positive 1/10. I drew it down here at negative 1/10, which made this whole part of my graph wrong. Okay, so let's fix that real quick. Sorry about that. So most of the work we did was correct, except I put the y-intercept on the wrong side of the x-axis because I thought it was negative for some reason. I guess I looked over here. Negative over negative is positive, so it is positive 1/10. So our line, this line here should have been like that. Because if the y-intercept's on the top side, then the graph, when you connect on through, comes down from the top side. If we check that against our answer here, we'll see if everything is lining up nicely. So we have this curve down here, which works out good. We have the vertical asymptote at -2. Now that my y-intercept's on the right side, my graph comes down, passes through the y-intercept, hits the x-intercept, and continues on down. And then we have our other vertical asymptote at 5, and then the last bit's on the top side. So really what happened was I plotted my y-intercept on the wrong side of the graph, so that made this chunk right here, this part of my graph here, not on the right side. But now we got it fixed, so everything's working out good there, and we'll move on to the last two examples here. So last two graphing thing, and then we'll wrap it up. So next example. Here we want to graph y equals x squared, let's say minus 4x minus 5, all that over x plus 2. So I want to graph y equals x squared minus 4x minus 5, all that over x plus 2. So in order to do that, we're going to need to find our x-intercepts first. So this is who makes the top equal to 0. Top is x squared minus 4x minus 5. Unlike the previous ones, I can't just look at this and tell what it is, so I'm going to need to kind of factor it. So I set the top equal to 0. It's going to be a -5 and a +1, so I get x minus 5 is 0, which is x is 5, and I get x plus 1 equals 0, which says x is -1. So for this one, I got two x-intercepts. For the y-intercept, this is going to be what happens when we set x equal to 0. So if I put 0 in for all my x's, I want to see what do I get back. I get a -5 over 2. So that's my y-intercept at -5/2. For vertical asymptote, this is who makes the bottom equal to 0. The bottom is x plus 2. If we think about it for a little bit, we say, okay, what x value do I plug in that makes x plus 2 equal to 0? That's going to be x equals -2. This one, since the degree of the top's bigger, we have an oblique asymptote. And so with the oblique asymptote, what we're going to do is we're going to say, all right, this occurs at y equals the division of the top, the quotient of the division of the top, which is 1, -4, and -5 are the top's numbers. So we actually perform the division. The bottom's x plus 2, so a -2 goes there. We can use synthetic division since the denominator is of the form x plus k. And the oblique asymptote occurs at y equals the quotient of the division. So we bring down the 1, -2 times 1 is -2, -4 plus -2 is -6, Negative 2 times negative 6 is positive 12. Negative 5 plus 12 is 7. So this is no x's number. This is x to the first power's number. So y equals x minus 6. That is our oblique asymptote in this case. So then we want to say, do we cross the oblique asymptote? So I set the x minus 6 equal to my entire function, x squared minus 4x minus 5. All that divided by x plus 2. And I see, does this have a solution? So I'm going to multiply the x plus 2 across. So we get x minus 6 times x plus 2 equals x squared minus 4x minus 5. We FOIL it out. We get x squared plus 2x minus 6x minus 12 equals x squared minus 4x minus 5. So I get x squared minus 4x minus 12 equals x squared minus 4x minus 5. I can subtract x squared from both sides and they cancel. I can add 4x to both sides and they cancel. And so I get negative 12 equals 5. So no, in this case, negative 12 is never 5. So there is no crossing the oblique asymptote. So now we need to graph this thing. So let's create, that's not good. You know, let me just use the line tool here. That's better. Okay, so x-intercepts are at 5 and negative 1. So we say, okay, out here at 5. And again over here at negative 1. Those are my x-intercepts. My y-intercepts at negative 5 halves, which is negative 2.5. And make sure, let me look at it again and make sure I got it on the right side of the graph, because last time I put it on the wrong side of the graph and that messed everything up. It is negative 5 halves, so that should go in the right spot there. Vertical asymptotes at negative 2. So we have kind of this dotted up and down line at negative 2. Now for the oblique asymptote, this is the line y equals x minus 6. So it has a y-intercept of negative 6. And to get points on the line, if we go up 1, right 1, 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 and it should cross out here at 6. And so we can kind of just go through with our dotted lines and say, okay, here is our oblique asymptote. So we have it kind of like this. So we got to decide for the first part of our graph, do we have a line that's kind of, whoops, do we have a line that comes in along the oblique and heads up towards the vertical, or do we have a line that's kind of along the oblique and down with the vertical? So again, we're going to use where x-intercepts occur. There's no x-intercepts out in this region, so that's going to force this part of the line to be kind of down here like that. Then for the rest of the graph, we have these 3 intercepts that are all on the top side. The only way we're going to be able to pick those intercepts up is if our graph is in the top side like that. And then this should be pretty close to what our graph looks like. Let's take a look at Desmos real quick just to make sure that we don't have any other mistakes with it like we did in the other one. So let's see here. We want x squared minus 4x minus 5. All that divided by a x plus 2. And so that graph is looking kind of like this. If we compare that to ours, they look pretty similar. Like this right here, actually, this turnaround kind of occurs a little bit different point, but it's a little bit further down. But everything looks like it's lining up pretty well. Okay, so let's look at one final type here, and then we'll say that that's good for 3.5. Um, so final example type. Let's say we had, we want to graph it again, and let's say we have y equals x squared, let's see here, minus 2x minus 15, all that over x squared, let's say minus 2x minus 8. So we want to graph this expression. So again, we got to find x-intercepts. So that's who makes the top equal to 0. So the top is x squared minus 2x minus 15. We set it equal to 0. So I go through and I say, okay, what are two numbers that multiply together to be negative 15 that could add up to negative 2? It's going to be a negative 5 and a positive 3. So x equals 5 is one of my x-intercepts. X equals negative 3 is another x-intercept. For the y-intercept, we set x equal to 0. So we put 0 in for all our x's. And then we see what we get back. And what I'm getting back is negative 15 over negative 8, which is positive 15 eighths, which 16 eighths would be 2, so this is 1 and 7 eighths. So it's a little bit less than 2, and it's a positive number. For the vertical asymptote, we say, okay, where is the bottom equal to 0? So the bottom is x squared minus 2x minus 8. Where is that equal to 0? We can factor that. Two numbers multiplied to negative 8, add up to negative 2 is going to be negative 4 and positive 2. So x equals positive 4 is one vertical asymptote. X equals negative 2 is another vertical asymptote. For the horizontal asymptote, we are in a case where the degree of the top and the degree of the bottom are both 2, so the degrees are equal. So it's y equals leading coefficient of the top, which is the 1. It's the one that's sitting in front of the x squared, over y equals leading coefficient of the bottom, which is also a 1. So we get y equals 1 over 1, and 1 over 1 is 1. So the final thing here we got to check is, do we cross our horizontal asymptote? So I'm going to set 1 equal to the whole function, x squared minus 2x minus 15. All that over x squared minus 2x minus 8. Okay, so we are going to multiply this on up. So we get x squared minus 2x minus 8 equals x squared minus 2x minus 15. We can subtract x squared from both sides. They cancel. We can add 2x to both sides. They cancel. We get negative 8 equals negative 15, which doesn't make sense. So in this case, no, they don't actually cross. So let's put all our information on our graph and see what kind of happens. Okay, so we got, let me use line tool again. So we got something like this. Okay, x-intercepts are at 5 and at negative 3. So out here at 5, we got one x-intercept, and back here at negative 3, we got our other x-intercept. Our y-intercept is at positive 15 eighths, which is 1 and 7 eighths. So it's basically right here, just below 2. Vertical asymptotes at positive 4. And again at negative 2. And our horizontal asymptote is at 1. So this is the type where we're going to use where are our x-intercepts and where are they not in order to determine where stuff goes. So I'm trying to decide, do I have a curve up here or a curve down here? Well, if I'm going to clip that x-intercept down here, my graph has to be kind of on the downside. Then I say, well, do I come up from the bottom to hit this intercept, or do I come down from the top? I'm not able to cross I can't cross my horizontal asymptote, so that's going to force this to come down from the top. And then I still can't cross my horizontal asymptote, so that's going to force me to head back upwards on this side. I can't go on through and head downwards because I can't cross that horizontal asymptote. Then if this final dot's down here, that's going to force the rest of my graph to come up from the bottom, clip the dot, and go over. And that should be our graph. Again, one last time, let's graph this in Desmos and just verify that everything is looking good and we don't have any mistakes. And so our graph in Desmos looks kind of like that. And we can see we have kind of this bottom part. We have kind of this top U shape. And then we have another bottom part. So that's kind of going to do it for 3.5 recap and issues. And so we'll stop there. And we're going to do 3.6 next and then 4.1.